Okay, so the merry-go-round speeds up from something to something, right? So our delta W is, what is that? Is that 0.70? 0.70, I want to say that. 2.1 minus 1.4. Sad if I'm wrong, you know. That's radians per second, right? And ultimately what we're going to do is we're going to set up a torque times time. So force times time, right, is mass change in velocity. Only in rotational land, this is mass is moment of inertia, and change in velocity is change in angular velocity, right? And so already we've got one of these numbers. There's our omega. 4 seconds, that would be our time, right? So we know this guy. We know this. We got to figure out I, which is, I think, probably the hardest part of this, right? So let's figure out I. I is going to be the merry-go-round, right, which is, of course, a 160 kilogram cylinder, right? So it's 1/2, and look up the mass of that. That's 160. And I'll give you all these moments of inertia on the little assessments. And then R is 2. Right? And then if there's a child, if there's some object, some distance, just make that an mr squared. So our formula is 1/2 mr squared for the merry-go-round plus mr squared for the kid, right? So they are 45 times 1.8 squared. So let's just figure this out. So 0.5 times 160 times 2 squared. You could have told me that was 320. Plus, let's see, 45. 145.8. 45 times 1.8. And then we're just going to add that to 320. 465.8. Kilogram meters squared, right? So now we're set. We can find now we can find the torque, right? So torque times 4 seconds, right, is equal to 465.8 kilogram meters squared, right, times let's see, our delta is 0.70 radians per second, right? Okay, so I just have to do this guy times 0.7 divided by 4. 81.515. Right, how is that meter newtons? You can, by the way, stop right now if you don't care how that is actually meter newtons, right? Let's see, it is, the actual units are kilogram meters squared per second, because I divided by seconds, right? Times radians per second, which is so they are actually kilogram meters squared per second squared. So let's see, this guy has the units of meters times kilogram meters per second squared. So that is definitely kilogram meters squared per second squared, right? So this is the units of that, of all this. This is the units of torque, and they're the same. They're, by the way, that's the same units as joules, but it's not energy.